So, hello student. In the last session, we have completed our electrostatic part 1 finally, and now we are going to start electrostatic part 2. In electrostatic part 1, we have taken 75 PPTs, so it's very small chapter, I hope. Now we are going to start electrostatic part 2, and it is also going to be a very small chapter. Okay, so so let's start. Here you are saying small is small, but if I pages that much big. Okay, so let us start our electrostatic part 2. Electro electrostatics part, correct? This is our new topic we are going to start, correct? So before starting this new topic, I want to first discuss about the electric flux, okay, because that is going to be our first topic. Before going into the electric flux, I want to first discuss with inside this something called as a area. Everyone know what is area? First, my first question is that first we will going to discuss about area. In discussing first thing about area, my first question is that whether area is a scalar quantity or vector quantity. It is a scalar or a vector. First you tell me whether it is a scalar quantity or a vector quantity. It is a vector quantity. First thing is it is a vector quantity. Some people think that it has a scalar quantity, but it is a vector quantity. So if I ask you, suppose I have a circle, or yeah, suppose I have a circle. Okay, my question is that, okay, if it is a circle, like try to think like this, if it is a circle, so can you tell me what is area? What is the area? Okay, what is the area? With magnitude as well as with direction, I want to know the both the thing. Suppose this is my x and this is my y, okay, and it is placed like this. It is placed like this. Clear? Okay. So what is the area? Area will be, suppose the radius is r and this is its center. What is the area? Pi r square. Then what is the direction? I want to know the direction. Magnitude everyone will tell. What is the direction? It is plus j cap or it is minus j cap. Which one is correct? Both are correct. Answer is both are correct. Okay. Both are correct. Now the question is that how to find the direction? How to find the direction? See, magnitude you can write, that is not a problem. See, if we try to understand, we have a two types of surface out there. We have a two types of surface. Clear? We have two type of surfaces. Okay? We have two types of surfaces. See, this chapter you have to follow me. Okay? All the question will be from notes only. They cannot frame any question beyond this notes because it is a quite theoretical chapter. Not that much numerical part is there. Yeah, there is things are there. Numerical portion is there, but it is slight difficult chapter than the electrostatic part 1. Okay, so you have to follow me completely. So there are the two types of surfaces are there. If you know, one is, what is that? One is 2D and one is what? 3D surface. Okay, one is 3D surface. Similarly here we have a 2D surface. For 2D surface, the direction is perpendicular to the surface. The direction is perpendicular to the surface. Means suppose this is my one rectangle. Okay, so what is the direction? You can take either this or either this, no issue. Okay, you can take either this or either this. That is not a problem. Both can be the answer. because it should be perpendicular to the surface. So direction will be either plus j or either minus j, not a issue. But suppose we have a closed surface, then in that case the direction is perpendicular to surface, but it is outward normal. Outward normal. What do you mean by outward normal? Let me tell you. Let's take one example, then you will understand better. Suppose suppose this is my cube, correct? It is a 3D or a closed surface. You can say it is a 3D and closed surface. 3D means closed surface basically. Okay, so this is a closed surface. Now if I ask you what is the area of this, so what is the direction of the area? Okay, so here if I want to point out the direction of the area, so for this surface the direction will be like this, for this surface the direction will be like this, for this surface the direction will be like this, for this surface the direction will be like this, for front surface the direction will be like this, for back surface the direction will be like this. Means it will be always outward normal. You can't say I will take the direction vector like this. No, it is wrong. You have to take always outward normal. Okay, you have to take always outward normal. That is a concept. So for just try to understand what I am trying to say. If it is a 2D surface, you can take any above or down, that is not a problem. But if you are taking about the 3D surface, then in that case my direction vector or my area vector will be always perpendicular to the surface, but it is always outward normal. That is a condition. Clear? Any doubt? So if I ask you, for this it is, sorry, yeah, for this it will be plus j. If it is a not plus j, I am taking this as, this will be plus I, this will be minus I, this will be minus j, similarly this will be plus j, correct, for this surface. Any doubt? This is how you find the area vector. First thing is that area vector, you have to be very clear about how to write the area vector. Clear? Let's take one more example, then you will understand better. One good example. Let us take example. You have to write the area for me so that I become confident that you know how to write the area vector. Okay. Just write the area for me. Suppose this is my x, this is my y, and suppose this is the z axis. Okay, this is the x axis, this is the y axis, and this is the z axis. Clear? Okay. Tip is not here. Let me try to draw it. Can't draw. Yeah, somewhat I draw it is basically somewhat I have tried to draw. This is 30 degree. Okay, somewhat I have tried to draw. This side is suppose 2 meter. Okay, you have to find the area vector. I want to know the area, or basically area I want to know. So obviously you have to tell me the magnitude as well as the direction. Just tell me what is the area. Means try to understand. It is keep like this. Okay, this is my x, this is my y, so it is keep, and this is my z, so it is keep like this, correct? Now you tell how to find the area vector. Written? Okay. See, this is 2 meter, so what is the coordinate you can write here? This will be 0 cos 2 comma 0. What is the coordinate here? This is 2. This will be 2 cos 30. 2 cos 30 means root 3. So x will be root 3. 2 sin 30. What is this will be 2 sin 30. What is the y coordinate? 0, because it is in xz plane. 2 sin 30, that is 1 meter. Correct. So this is the coordinate I got. And what is the coordinate here? This is 0 comma 0 comma 0. So what is the suppose let's take the point A. This is B. This is C. And this is D. So what is my AB? My AB vector will be how much? That is B minus this is B minus A, so it will be 2 j cap, correct? And what is my AD vector? So this will be root 3 I cap plus j plus k cap, correct? So my area will be how much? If you remember, that will be AB cross AD vector, correct? AB cross AD vector. Now do the cross product. So this will be I cross j is how much? If I cross j is I into j, or it is better to, yeah, okay, let's do AB cross AD only. So j cross I, that is minus k. J cross I is minus k, correct? And j cross k is I. So this will be my I vector. This is my area. This is my area, meter square, correct? So this is my area. Clear? Oh, sorry, 2 is there, no? It will be so this will be 2 root 3. This will be 2, correct? Any doubt here? So this is how we write the area. I hope now you are confident and you can tell me. If I give you any shape, you can tell me the area. Okay, clear? Any doubt is here till now? Everyone know how to write the area, how to write the area vector, and how to tell me the direction of area. Basically, if I ask you to tell me the direction of area, you can tell whether it is a closed surface or it is a open surface, no doubt. Clear? Okay. Now let us try to understand the very important thing, that is electric flux. What is electric flux? I will go very slowly. Just try to understand the things very properly, because this is the which part where a student face lot of problems. Okay, but I want you to follow me. You can solve all the questions. Not a single problem will be left. You follow me. Okay. So what is electric flux basically? See, suppose I have some surface like this. Okay, this is my surface. Clear? And suppose the electric field lines are going like this and it crossing the surface. Okay, so what is that electric flux is defined? How we have defined the electric flux? We have defined this, sir. Electric field is what? Electric field is nothing, it is the electric field lines. Exactly, it is lines? No, it is something like that, something different it is there, but for us convenience, for our convenience to study it properly, we define it as a lines so that we can study. So suppose we have some surface like this, and the electric field lines are crossing the electric field lines are crossing this surface. So what we can see, electric field is what? It is the energy that we have seen in the infinite sheet. It is a form of energy. So the energy is crossing the area, some area it is crossing. Now if you tell me, if I increase the area, more number of energy will cross, or you can say more number of electric field lines will cross the surface. Correct or not? And if I increase the electric field also, the more number of electric field, more number of energy will cross the surface, correct? Yes or no? And if suppose I keep the surface like this, this is my surface, now surface is like this, clear? And the electric field lines are going like this. So how many electric field lines now crossing the surface? 0, because the surface is like this, and the electric field lines are going like this. So there is a no crossing, the electric field lines are not going to cross this surface, correct? So what we understand from here, electric flux is nothing. It is defined as the measure of the energy of an electric field lines. It is a type of quantity which is used to measure the energy of electric field lines. Or in better way, if I say electric flux is nothing, it is a count of electric field lines. Simple. Because more number of electric field lines, more will be the energy. So similarly, we have defined the electric flux as nothing. It is the measure of, or it is a count of number of electric field lines which is crossing the surface. But here the definition is not complete. If you see in the last case, if I keep the surface like this and the electric field lines are like this, how many electric field lines are crossing the surface? 0. So there must be some condition na, between E and area. So what is that condition? Now listen the complete definition. Electric flux is defined as the number of, or you can say count of, electric field lines which are crossing the surface that is perpendicular to the area. That is perpendicular to the area. Clear? So what is basically we have defined? It is the it is the count of number of electric field lines that is crossing area perpendicular to its surface. Correct? Any doubt here? So that is how we have defined the electric flux. And what is that value? The electric flux is defined as phi, which is defined as integral E dot dA, closed integration for a closed surface. This is for closed surface. For closed surface, E dot surface, E dot dA. And what is that E vector? What is that dA vector? We will discuss. And for open surface, the flux will be E dot dA for open surface. Simple. That is why we have discussed about the area, because here we are going to use that area vector for open surface. Where phi is what? Its unit will be what? Newton per coulomb meter square. That is defined as Weber. Clear? And also one more thing, if E is equal to constant, if E is constant, so my phi will be how much? E dot A. If E is constant, electric field is constant, that you can directly apply this formula. Correct? Any doubt till here? Anyone have a doubt? Please tell me. Okay, no doubt. So this is how we define the electric flux. Clear? Any doubt is there? Okay. So electric flux is nothing. It is measure for a closed surface. That is a formula. For open surface, that is a formula, and that is for a constant electric field. Clear? Any doubt? Basically, see, this is the real concept of an electric flux. This is the real formula, or you can say real concept. But in reality, we are reality for a calculation aspect, we always prefer this formula. But in our coming topic, there we will introduce the one law, that is something called as a Gauss law, which is going to make our calculation for electric flux more easier. Okay, and that law is coming from this concept only. So you have to understand this concept properly. That is what is my electric flux. So let us solve some examples so that we can get a good understanding of it. Clear? So let us take one example. You have to tell me what is the electric flux. You know, now you know about the area vector, because I told you what is the area vector completely, and you also know about the electric field. That is why we have first read the electric field, and then we go for the area vector. Because see, remember, my lectures will be going to be in proper sequence, so that you can understand each and everything properly. If you are following, you can understand each and everything. So let us take one example. Suppose this is my ring, correct? This is my ring, or suppose the electric field lines are going like this, correct? Suppose the radius is r and this angle is suppose 30 degree. You have and the electric field is constant is equal to E naught. You have to find the flux. What is the flux from this? Okay, just tell me what is the flux from this surface. What is the flux from that surface? Okay, what is the flux from this surface? Tell me. This is a uniform only. Okay, it don't look, but you treat it as a uniform. The radius is r. Now you tell me what is the flux. What is the flux? See, a electric field is constant, so we can apply this formula. Yes or no? E dot A. Now what is the area vector? Area vector is E. E is electric field dot into A into cos theta. What is the theta? Theta is 30 degree. Theta is 30 degree. Yes or no? No. What is the direction of area vector? It is perpendicular to the surface, na? So what is the angle between electric field and theta? That is 60 degree, not 30 degree. So this is 60. So what is the value you will get? E naught, area is pi r square into cos 60 is 1 by 2. So that is E naught pi r square by 2. That is my flux. Here, what is the flux? What is the flux? What is the, can we apply this formula? Ea cos theta. What is theta here? You have to tell me. It is 45? No, it is 90 degree. This angle is 90 degree. See, try to understand. This is the surface and electric field lines are going like this. Okay, it is just touching the surface like this. Okay, grazing the surface. That is something called as a grazing incidence. If you read about ray optics, there you will understand. This is called as grazing incidence. So theta is 90. So my flux will be 0. Clear? Any doubt? Note it down. Clear? Okay, let's take one more example. This is a NCERT example. Okay, in NCERT you will find similar type of question, but I am taking first smaller, some easier version, then I will go to that type. Okay. Okay, this is thing. Basically, this cube is placed on this line. It is not looking like that, but is there. Okay, just assume it is placed there. Okay, not looking. Okay, so it is placed on that this thing. Okay, this is x, this is y, and this is my z. My electric field is E naught is equal to, sorry, not E naught, my electric field is my electric field is my electric field is E naught x into I cap. This side is side of the cube is A, correct? Suppose this distance is L, everything is given. Now you have to find phi net, total flux through this cube. What is the total flux through this cube? Do we need to do integration or what? You have to think. You have to tell me what is the net flux through this surface. Let's think. What is the net flux through this surface? See, electric field is variable. It's not. It is correct. But at this point, you see, at this point, what is my x coordinate? At this point, what is my x coordinate? At this point. For this surface, if you see for this surface, the x coordinate is fixed. So the electric field will be constant for this surface, yes or no? So for this surface, the electric field is constant. See, first tell me by which surface the flux is 0. See, the flux will be 0 from this, and this. Why? Because the electric field is in x direction. The area vector for this surface is y direction. So the angle between the electric field and the area vector will be 90. Obviously here the electric field is in this direction. Nah, this is my electric field, correct? In I direction, that is given. That is the direction of my electric field, correct? So this is my electric field direction. For this surface, my area vector is this direction. So obviously the angle will be 90. So the flux through this surface will be 0, correct? Similarly for this surface also, the phi 2 is also equal to 0, correct? Similarly for front and back, both the surfaces, the electric field is flux is 0 for this surface, front surface. Again my phi 3 is also equal to 0, and similarly for back side, my phi 4 is equal to 0. So only the two surfaces are left, this surface and this surface, correct? These two surfaces. Now for this surface, the x coordinate is fixed, this coordinate is fixed, x coordinate, or the electric field for this surface will be constant, correct? So what I can write, if the electric field for this surface is constant, I can apply the flux formula, that is phi 5 is equal to this formula. I can apply E dot A without any problem. What is the electric field? It is E naught. What is the x coordinate? L plus A into area. What is the area? A square. And what is the angle? The angle will be how much? See, now for this surface, the area vector will be outward and the electric field is inside. For this surface, the area vector will be outward and the electric field in this side. So the angle is cos 180 degree. So from here you will get minus E naught into L plus A into A square, correct? This is my phi 5. Now what is similarly what is phi 6 for this surface? For this surface, if you will see, that is for backside surface. Let me draw erase this, otherwise you will be confused. Okay, that is for backside surface, clear? Now for this surface, the dA vector is in this direction only. This is my dA vector, correct? For this surface, this is my dA vector, and that is the electric field also. So they both are parallel to each other. So I can write for this surface the same thing. Yeah, for this surface also the same thing. My electric field is constant for this surface. So it is E naught into L plus 2A, correct or not? Or I did something wrong. It is L plus A. Oh, sorry, there A should be not here, no? Okay, sorry. The coordinate is L, na? Not L. Just tell me whether if I am doing some wrong thing. Just tell me. Okay. A naught L into A square, correct? This is my 5. Here E naught into L plus A into A square. So what is my phi 6? So my net flux will be E naught into L plus A into A square. Sorry, A square. So what is my phi total? Phi total will be 0 plus 0 plus 0 plus 0 plus this value E naught into A square into L plus A minus L. This will cancel out. You will get E naught A. That is my phi total. Clear? It is very easy. There is no need to do any integration. If some person are writing and doing integration, there is no need. Okay, you have to see individually each surface because it is a 3D. So you have to see each and every surface, because for different surface there will be different normal direction for normal. So you have to see each surface individually and you have to calculate. Correct? Any doubt here? Okay. So let's take one more example. Okay. Now in this example, let me do some changes. Sorry. Just try to understand how it is kept. Okay, it is kept like this. Okay, side same, side is A. Okay, and what are the other things are given? And suppose my electric field is some E naught. We can take 2x I cap plus 3 or y j cap. That is my electric field. Okay, now this is my x, this is my z, and this is my y. Correct? And the side is given. Now you have to find phi net. Now, is there is need to do the integration here, or let me for you? Yeah, let's do it. Or for you, let me make it little easier. Okay, we can do tough, but for now, let me make it. I'll change here. This we have to do. Okay, let's do it. No issue. Yeah. So, or we can do one more thing here. If we place it here, suppose okay, let me do one thing. Let me draw it again. Leave it. Let me draw for you. Let me draw this again. Okay. Correct. Now, yeah. Now it is okay. Yes. Now you have to find the total flux. Yeah, do it. Calculate and tell me what is the total flux through this surface, through this tube. What is the total flux? What is the total flux? See, let's see each and every surface one by one. Let's see for this case 2x I cap. Okay, for break this. Let me take first the I component. If you see the I component, it is sure that from 4 surfaces the total flux is 0. Which are the 4 surfaces? Front, back, up, above, and down. This for these 4 surfaces the net total flux is 0. Only we get the flux from this surface and this surface. Correct. So what is the flux for these 2 surfaces? That is, let me write as phi 1. From this surface, at this point the x coordinate is 0, so that means the electric field will be 0. Only we will get for this surface, that is A. So we will get electric field as 2A, and the area is also what? Area will be how much? A square, correct? So we will get 2A cube. That is my total flux. Similarly, now let's see for Y. For Y, if the electric field is in this direction, for which two surface the net flux will be 0? Let us think. The electric field in this direction. For this, and this surface and this surface, the net flux will be 0, correct? So for this two surface, if you see, for here, this surface, the electric field here will be 0 because the Y coordinate is 0. Only we will get the electric flux due to this surface. Why the electric flux from this surface we will get, and what is the coordinate of Y? The Y coordinate will be A. So what is the flux we will get? The phi 2 for that surface will be, electric field will be A into, that is A square. So this will be get A cube. So what is the total flux? Phi total, that is 3A cube. It is a very tough question if you know. This type of questions are considered as a tough question. If I place it here, it will become more tough. But if you understand, it is very easy. There is nothing rocket sciences here. It's very easy. Just you have to understand the things. Okay. Let me give you one homework problem. Same question. The same question. What do you do? In the same question, you just do one thing. Okay, sorry. Do one thing. The same question. I will do only one small change. The same question, and you have to solve it. That is the previous case. For this question, here the cube is placed here. Now you just do one thing. Now suppose the cube is placed here and everything is same, and suppose this distance is given as 2A. Now you tell me what is the total flux. This is your homework question. Okay. Now you tell me what is the total flux. If you are able to think that, you can understand, then it is not very simple to solve this. Okay. I will discuss in tomorrow session. Okay. So let's take one more example. Okay. Let's take one more example. Okay. What is the example? Suppose there is a charge Q is there. Okay. And suppose I place a ring. Okay. Suppose I place a ring, and this is charge is placed at the center, and this is the ring. The radius of the ring is R. R is a radius. The radius is R, and suppose this distance is given as x. You have to find the phi total. What is the total flux through this ring due to this charge Q? How to do this? Not ring, take it at disk. If it is a ring, then it will be 0 na, because whatever the number, take it as disk, not ring. Okay, take it as disk. So for disk, what you do, one thing, take it at disk. This is my disk. Okay, and the radius is R. It is a disk because it is filled. Okay, now you have to calculate the what is the total flux. So this surface, how to do? How to calculate the total flux? First of all, you tell me here the electric field is constant or variable. Electric field is variable, obviously, because the electric field will be different at different point. Okay. Now second thing, you tell me whether it is a closed surface or open surface. It is an open surface. So which formula I have to apply? I have to apply phi is equal to integral of E dot dA. Correct? That is the formula I have to apply. So what is the I will do? I will go from center at distance R, and I will cut a small element. It is not possible to draw here. Like I will go from center a small distance R, I will cut a small element here. Okay, I will cut a very small element. Let me draw here for you, then you will understand what I am trying to say. Like see, this is my disk now. Okay, this is my disk. What I am saying, what I'm saying, I will go from the center at distance r and I will cut a small element, okay, whose thickness will be dr, correct, whose thickness will be dr. That is the first thing, whose thickness will be going to be dr from the center. This element is going to be cut from the center dr. And what is the length of this, like what is the area, dA area? Can you tell me what is the dA area? That will be 2 pi r into dr, correct? Correct. Okay. Now, what is the electric field due to this ring, small ring? Can you tell me what is the, like, see the electric field to this charge. So if you see, the electric field will be like this, but the what is the dA vector due to this? The dA vector will be like this, correct? If this angle is theta, this will be also theta. So this is my electric field, and this is my dA vector. So what is my dA vector, correct? So what is my this? I can write it as the electric field is not constant. What is the electric field value? That is kq by what is this distance? This is x, this is a small r, so it will be x square plus a small r whole square, and under root this will be cancelled out, so you will get kq by x square plus r square, correct? What is my dA vector? So you have to take, and what is the angle between them is theta, so this will be dA means area, area is 2 pi r dr into cos theta, correct? Any doubt here? So what is cos theta now? Cos theta now, can you tell me what is cos theta now? Yes sir, what is the cos theta? 2 pi r dr. What is cos theta? Cos theta will be how much? That is x upon x square plus r square okay, x square plus r square to the power 1 by 2. So what is my electric field? What is what is my total flux? Then it will become whatever is the constant, take outside. K, q is constant, 2 pi is constant, x is constant or variable, x is also constant, correct? So what is the thing we will left? X r upon r square plus x square to the power 1 by, sorry, not 1 by 2, it is 3 by 2, correct, into dr. Now you have to integrate this. Integration I told you, what is the limit of r? R is from r equal to 0 to capital R. What is the integration of this? If I put k is equal to 4 pi epsilon naught, how much I will get? I will get q by 2 epsilon naught into x, correct? If you do this integration, if you remember, the result will be 1 upon x into, sorry, if you remember this result, it will be 1 by x minus 1 upon root over of x square plus r square. This is the integration of this thing. If you integrate, you will get this. Now multiply x inside, you will get q upon 2 epsilon naught into 1 minus x upon root over of r square plus x square, correct? This is the total flux crossing through this disk due to this point charge, q upon 2 epsilon naught into 1 minus x upon under root of r square plus x square. Clear? Any doubt here? See, you can see q epsilon naught, q by epsilon naught, that is giving a feel of Gauss law only, that we will understand. See, this is the correct, you can say this is the conventional method, but I will tell you the short trick by using solid angle. You can solve this question just in one line, okay, just in one line, not more than one line. Till now, just you remember this method, but when you understand the solid angle, what is solid angle, you can solve this in just in one line, okay? Till there, note it down. If anyone have a doubt, please tell me. Please note it down. Completed? Okay. Clear? Okay. Let's do some like something and try to understand some type of thing. Okay. Suppose there is a closed surface. Suppose there is a sphere is there. Okay. Let us think there is a sphere is placed here. Okay. This is a sphere. Okay. This is given that this is a sphere. Suppose this is my sphere. Okay. This is my sphere, and suppose the electric field lines are going like this. Okay, like this. So if I, and there is a capital Q charges here, electric field lines are going like this. This is a sphere. I ask you, what is the total flux pi by that Q charge in this? What is the total flux? Can anyone tell me what is the total flux? What is the total flux? 0. Why? Why is 0? What is the reason why the total flux is 0? If you try to understand, see, at this point, my electric field, my area vector will be like this. So what is the angle between the electric field and the area vector? It is some acute angle. Here my area vector will be like this, correct? So what is the angle between the area vector and the electric field? It will be some obtuse angle, correct? So here the electric flux is positive, and here the electric flux we are getting is negative. So my overall total flux will be 0. Or you can also see what is the electric flux. It is a count of number of lines that is crossing the surface. Here you can see the number of lines which are entering inside the surface, the same number of lines are also coming out of surface. So overall, obviously the total flux will be 0, correct? So what is the conclusion we have got? If suppose I take some any random surface, not like this, I take, let's take some any random surface, any random. It is not necessary. Like you take any random surface, okay, it is some random surface, it is there, okay, some random surface, something is there. Okay, let's take some random surface as given. Okay, some random surface, some random closed surface is given like this. Time taking process. Let us this some closed surface. Okay, and for this surface, if I place a charge Q here and I ask you what is the total flux, suppose electric field lines are going like this, what is the total flux? You will tell. Again, the total flux that Q will be 0 here. No need, it doesn't matter whether the shape is something proper shape or it can be anything. So what is the conclusion we have got? If we place any point charge or any charge outside the closed surface, then the total flux crossing that closed surface will be always 0. That is a conclusion. So conclusion we have drawn from here is, these all conclusions are very important for solving the question. Okay, so you have to understand this thing. Sorry. So what is the conclusion we have drawn? The conclusion we have drawn is that if we place, if an charge, if charge is placed outside the closed surface, then the total flux through the closed surfaces is 0, correct? That is a conclusion we have drawn from here. The total flux through the closed surface is 0. Okay, that means if we place any point charge outside the if we place any point charge, okay, outside the closed surface, the total flux is 0. From here only we will obtain the Gauss law. This is going to be the statement of the Gauss law. We are trying to understand the Gauss law. For that we are doing this conclusion and this observation. Clear? So in the next class we will proceed from here only, and we will finally go and understand the Gauss law, and we will go to calculate the different electric fields from the Gauss law, and we will see the solid wire, hollow wire, which we have not seen earlier, because the derivation by the Gauss law is slight easier as compared to the derivation, normal conventional derivation. So we will understand this, and then we will move to the conductors, and there we will study about the conductor and equipotential surface and everything, and then finally this our electrostatic part 2 will be finished. Till then, take care, goodbye, like it, subscribe it and share it. Have a nice day. Thank you.